Today we're going to talk about an example of using or applying the distance formula to solve a problem. Okay, so in this example here we are given 3 points and we want to determine whether those 3 points lie on a right triangle or the vertices of a right triangle. So the first thing I would do is draw a picture and see in my mind, or at least gather what it is I'm going to have to do or to show to whether these are on a right triangle. Okay, so let's just draw a triangle. Okay, and let's just use, let's say, points M, N, and Q. Okay, now I don't know what order these are in. All I'm doing is writing a right triangle, so I know what's going on. Okay, now I know the distance here, distance M comma N, if this was true, if this was the accurate way I was writing it. Okay, and this is distance N comma Q. And this is distance between MQ. Okay, so now to visualize what I have to show. So I would have to show if these are vertices, if N, M, and Q are the vertices of a right triangle, then the distance between these 2 points squared plus the distance between these 2 points squared would have to equal the distance between these 2 points squared by the Pythagorean theorem, right? So, in other words, I would have to see if a squared plus b squared equals c squared, right? And if I can show that that holds, then it has to be a right triangle, right? It has to be. These points, these 3 points would have to lie as vertices of a right triangle. So that's the idea behind how we're going to show this or not. Now, if we can't show that, then they obviously are not vertices of a right triangle. Okay, they would be vertices of some other triangle. Okay, so let's see what happens. So first of all, we need to find the distance between the points. Okay, so let's just do that. Okay, so let's figure out the distance, and we'll calculate each one of these. So distance, let's just do M comma N. Okay, and then we're going to figure out the distance of M comma Q, or MQ, and we want to find the distance between, what's the third one? It'll be NQ. Okay, so we're going to use the distance formula for each one of these. So for MN, M and N, between these, we're going to do, again, we're going to do the difference of the x's squared. So again, it doesn't matter which way as long as we're consistent. So if we do MN, we're going to do 12 minus 5 squared plus 3 minus, didn't make my mistake, sorry, 12 minus a negative 2. Okay, be careful. Don't do what I did. I went to the wrong one. So x to x. So now I'm going to do 3 minus 5 quantity squared. Okay. Now, let's simplify this and see what we get. Okay. So we get 14, square root of 14 squared, plus negative 2 squared. Okay, now what's 14 squared? 14 squared is going to give us 196. Right? So that's going to be, yeah, 196 plus 4, right? Which gives us the square root of 200. Okay, so I'm going to write square root of 200. Okay, so I'm going to leave it that way for a moment. Now let's do MQ. So the distance between M and Q, now this is where you have to, again, make sure you do x minus x. So this is going to be 10 minus negative 2 squared plus, now we're going to do the y, so negative 11 minus 5 squared. And now we're going to simplify this, and this becomes 10 plus 2, so this is going to be 12 squared, which is 144, right? So 10 minus negative 2 is going to give us 10 plus 2, which is 12. 12 squared is 144. And then this is going to give us what? 16, okay, or negative 16 squared. So if you want to write it out, so this will be 12 squared, and this is going to be negative 16 squared. Okay, and then negative 16 squared is 256. And so if we add those together, we're going to get what? We're going to get 400. Right? So this is 390, yeah, 400. Okay, so let's just leave it as that. And then finally, NQ is these two. So now what I'm going to do is I'm going to do, now I'm going to do 10 minus 12 squared plus negative 11 minus 3 squared. And so this here gives us what? This is going to give us what? Negative 2 squared. This is going to give us a negative 14 squared. Well, this is going to give us the square root of 4 plus, and of course this is going to be 196. Right? Just make sure I did that right. So NQ, so it's going to be 10 minus 12. Right? And we get negative 11 minus 3. So yeah, so we're going to get square root of 200. Okay, now, here's my answers. Can I take any two of those and square it? So if I square all of them, right? So again, keep in mind, I need to find some combination of these where I can get a squared plus b squared equals c squared. Because these are the distances now, right? So if if these 3 points lie on a right triangle, then I should be able to take a combination of these distances where they'll fit into this pattern. And if you look, yes, it does. Okay? Because if this is A and this is B and this is C, C is always going to be the largest one. So if I take this squared plus this squared, do I get this squared? And the answer is yes, because a squared is 200, b squared is 200, and c squared is 400. And so it works. So guess what? These 3 points are the vertices of a right triangle. And that's it. Have a good day.